So inferential statistics. So this is, we found our sample, we found our x bar and our s. What do we do now? So there's several things we can do. The first thing we can do is if we don't know our mean, we can estimate it, right, with a confidence interval, saying mean is between these two things. That's chapter 7. Or if we do know our mean, but we want to compare our sample to it and see if our population differs somehow, we can do a test, right? So that's chapter 8 stuff. Or if we have two samples, we can compare them and see if they differ, find the difference between them. That's chapter 9, what we're going to be doing next. So if you pull out your chapter 9 notes, it looks kind of like that. So everybody get out your chapter 9 notes. We're going to be using those. We're going to go through chapter 9 and look at some different things that we're doing there. So again, grab your chapter 9 notes, inferences from two samples, chapter 9. And again, kind of look about what the goal is of the experimental survey. Why did you do it in the first place? So if you don't know your mean or your proportion, you want to estimate it, you do a confidence interval, chapter 7. If you do know the population mean or proportion, and you want to know if your sample, your population differs somehow, that's when you use a hypothesis test, chapter 8. But if you have two samples and you want to find the difference between them and see if they differ somehow, like one group is higher or lower than another group, then you would do a two-sample test. That's chapter 9. So, for example, you want to know if the proportion of kindergartners at a school, if the proportion of boys who own pets is different than the proportion of girls who owns pets, then you find those two, you take a sample of the boys to represent the boys' population, you take a sample of the girls to represent the girls' population, and then you compare those two samples so you can get an idea about their populations, if girls are more likely to own pets or boys, or if they're equal, right? There's some requirements. First one we're going to look at is first for a two-sample proportion. They have to be two independent samples, obviously, they can't be biased. And for each of the two samples, you have to have at least 5 successes and 5 failures. This is for a proportion. All right, so here's our null hypothesis. So this is the first thing you're going to be filling in that blank, right? The very first top of your chapter 9 notes. The null hypothesis is null. Null means no difference between the two populations. There's no difference, they are equal. H0 is always equal, so null hypothesis is that P1 equals P2. You can also write it as P1 minus P2 equals 0, because if they're equal, if you subtract them, you should get 0 difference, right? There should be 0 difference between them. So this is your first thing you're filling out. And then this is the second part you're filling out. So the pooled sample proportion is given by P bar equals x1 plus x2 over n1 plus n2. And then Q bar is just 1 minus P bar, where the P is the population proportion. You guys remember P equals x over n. This is kind of familiar, right? P equals x over n. And also, x equals n times P. So if I want to solve for x, I multiply both sides by n. So x equals NP, I think it's also in your notes there. So P is the population proportion, N is your sample size, X is your number of successes, how many yeses you had. So you should have those written in. All right, so now we're going to talk about when this happens. So what a P-bar is. So here's the idea of a P-bar. So say we have a bunch of boys, or we'll take our class. All right, so we have the ladies in our class, and say there's 20 ladies in the class, and of those 20, 6 of them own a dog, right? So 6 out of these 20 ladies own a dog, so their proportion will be 6 out of 20. And then we look at the boys, the guys, right? So the guys in the class, say there's 14 guys in the class, and out of those 14, 7 own a dog. So the proportion of the boys would be 7 out of 14 own a dog. So we've got 6 out of 20 for the ladies, 7 out of 14 for the guys. if we pull those together into one big group, right, carpool, right, pull them together, then we'll have 6 plus 7 people who own dogs, 6 plus 7 dog owners out of 20 plus 14 people. So that's the idea of the pooled numbers. When you pull them together, it makes them in one big group. And what's the proportion then? So that's where this p-bar comes in, the pooled proportion. So it's when you take your two, you have your first group, your x1 over n1, and your second group, x2 over n2. You have 6 out of 20 and 7 out of 14, and you pull them together. So I had 6 plus 7, 13 dog owners out of 20 plus 14, 34 people. So this would become my p-bar, and then q-bar is just 1 minus p-bar. Do 3 sig figs. So just find this as a decimal, put it into a decimal, and then write it as 3 sig figs. Don't do 2, I want 3. All right, so that leaves you to do lab problem number 1. So go ahead and do lab problem number 1, and I'll put you back in your breakout rooms. Go ahead and do that problem, those problems, and I'm only for like a minute. I'm gonna pull you back in like 30 seconds. I'll pull you back in, so a minute and a half, maybe 2 minutes. Your lab problem 1. Lab problem 1. Lab problem 1. It's right here. Right, Iswala? So yeah, if you don't have the notes, like James, I think you don't have the notes, it's right here. Here it is. I think I had it. Here also, it might be better, maybe bigger. There it is. So yeah, James, if I don't put the problem up that you're supposed to be working on, just remind me that you don't have the notes and I'll put it up so that you have it.